Hey everybody, how's it going? Time for our first distance learning lesson here. I'm pretty pumped up about it. Started whipping up this PowerPoint last night, pretty exciting. But I would be much more excited if I was hanging out with you guys in class tomorrow. It's also kind of weird because I'm literally talking to myself on a giant screen. But anyways, let's hop right into it. So today we want to start talking about, wait for it, comparing two proportions. So we've looked at one prop z intervals, one prop z test. We've looked at a bunch of stuff where we had one sample of categorical data. We learned how to use a one proportion z interval to estimate a population percentage p based on a sample percent p hat. We've also learned how to use a sample percent p hat to draw some kind of conclusion about the population parameter p, like did it increase, decrease, or just change with a hypothesis test. So now we want to start to look at, right, a lot of times in real life, like I don't just care about maybe the percent of people at East Hartford who take stats. Maybe I want to look at the percent of males who take stats versus females, or juniors versus seniors, whatever. So now I want to look at what happens if we have two different samples of data and how we're going to compare those. A little warm up for you. So I want you guys to take a minute, pause the video here. You got two pictures, a little fun one for you. And I want you to take a minute, pause it, and give me like 5 bullets or however many you want, whatever. Give me 5 bullets comparing these two images. But like seriously, pause it and do it for real. Like right now, pause. All right, so I'm pretty sure that if we were all hanging out together in class, some people might say something like both classes have a board, both pictures have like people in them, both have a monkey. But I think the majority are going to be things like this. Top picture's got like a snake within a tank. Bottom one's got a bird in a cage. Bottom one's got a fireman. Top one's got a policeman. Top one's got a bus stop. Bottom one's got a taxi, and right, so on and so forth. Got this mouse and this snake. This seems like a bad idea to tickle a snake with a feather, but hey, what do I know? So when you were asked to compare two images or two things, your instinct was to focus on the differences between them. And that's going to be the same thing we do when we're looking at data. When we have two different sets of data to compare, we're going to want to focus on the differences. But in statistics, right, we want to focus not on the differences between two pictures, but the differences in our sample statistics or in our population parameters. And so we take a peek here. Uh-oh, typo. This is just showing us whether we're talking about a two proportion Z interval or a two proportion Z test or a two sample T interval, two sample T test. This stuff's coming up in the future working with means. These are just the different ways we're going to notate those differences in either stats or parameters, the P's and the Mu's. So let's do it. So the first thing we want to do, practice. So although tedious, the best thing you can do right now, pause the video, write down this whole example in your notes, read through this. And one thing that I like to do when I'm reading through a context, so I would always read it first, just kind of quickly get an idea of what's going on. You want to go back, then reread, start to kind of pick out what the important information is, what's the question asking, what information do we need to answer what the question's asking, and hopefully this word right here jumps out at us about what we're going to have to do. But when I read through and I see I have two samples, I like to make myself a little table, and I apologize for the sloppiness here as I write with my mouse. Not that my handwriting in real life is even that much better, but I like to make myself a little table, right? So in this case, we got our over 30 group, we got our under 30 group, and then I like to list my like critical information for each. So this context gives us each p hat, and then it gives us our n, and then we're going to use those things to find our x value. And as I read through, I might also underline information relevant to the conditions because, like, yeah, we still got to do those. So take a minute, pause it, try to fill out a table, get a sense of what's going on. Unpause. And so here's my table, sloppily made. So not only does the table help us to organize, right, a lot of information, but another thing is, well, two things are, when we go to put everything in the graphing calculator, the calculator is going to just have a bunch of ones and twos. It's going to ask for x1, n1, x2, n2. And so this table, right, allows us to kind of keep track of which ones are the ones and which ones are the twos. The other thing is if we're going to use 1 and 2 notation, and that relates a little more to what you'll see coming up maybe Monday in a hypothesis test. But if we're going to use 1s and 2s, we have to give like a key as to which group is 1 and which group is 2. And so this table, right, does that. We can clearly see the over 30 is the 1 group and the under 30 is the 2 group. So this will satisfy that key element and also help us keep track of everything for the calculator. And this is all right stuff we know. We know what p-hat is, our sample percentage is, our x value. We know, like always, we have to round our x. Your calculator says error when you do the 2 prop z interval. There's probably two potential mistakes. One, you didn't round your x value, so you got to do that. You have to know that that's going to lead to an error. Or 2, occasionally people will flip their x and n, and your calculator is going to say error because x can never be larger than n. All right, so next up, we got to check the conditions. And now we got to check the conditions for each sample. So give the video a little pause here, and I'll float up here and check the conditions for each of the 2 samples. So here we go. So when we check the conditions for each sample, if you want to like just go below that table that you created and check the conditions separately for each sample, that's totally fine. If that's what, what works for you, that's what feels the most comfortable, do that. If you want to save a little time, I mean, you can try to combine things like, I only did it for 1 condition, but we can just say all 995 people were randomly selected in this case. 10% condition, right? Same deal as always over here. I had a mistake right there. That's for the black bar, but so whatever. So there's our 10% condition, and then same deal at the bottom. This one we can't, we got to do them all separately. Same deal as always, n times p-hat, n times 1 minus p-hat to be bigger than 10-ish. Right, so that's all stuff we know. Now with the conditions, so a little longer, but hey, if it's on the exam, like that's something we should get essentially correct. So don't view it as, oh, that's annoying, I have to do it. View it as like, hey, that's something that I can probably, get an E on. And we'll see what happens, what they say about this weird 45-minute exam we're going to experience. But with the conditions, anytime you have 2 samples, so now or in a couple weeks, whatever, when we're looking at 2 sample T stuff, there is 1 additional condition. So we've got to check the 3 we know for each group, but then also we're going to add what's now our independent groups condition. So we need, for instance, in this context, we need the percent of people who snore in the over 30 group to not be related to the percent of people who snore in the under 30 group. And if you're wondering, like, how could they be related? Like, I don't know, maybe if a dad is in the over 30 group and his son is in the under 30 group, maybe, I don't know, maybe there's some like genetic predisposition to snoring, I don't know. So with this condition, for us to believe that the 2 groups are independent, not related, the snoring rates are not related, it's really going to just come back to randomization. So some people even like to check this condition with randomization, and you might see that when I provide the key for our practice for today. Because since we got 811 random people in the over 30 group and 184 random people in the under 30 group, there's like no reason to believe what those snoring percentages are related, because it's one group of random people and some other group of random people. There's no reason to believe that there's a bunch of fathers and sons or mothers and daughters or whatever, siblings. So, and we'll come back to this at the end of the video, a little math action for you, bring back some review. Maybe hopefully that's making you think about something. But I don't even know what color that is. What color did I use? Whatever, that greenish color, it's pretty cool. That's the idea. That's what we got to know. Why did I make this font? Is it smaller? Anyways, I'm getting off topic. But this is how we're going to write it up. Pretty much you're just going to, you can do it pretty generically, which you guys know I'm always yelling at you about context, but we can get away, I think, with this one pretty generically. Just say our 2 groups. If I wanted to add context, I could say of people over under 30 right here are independent because the samples were selected randomly, or because all people were selected randomly. And if it's an experiment, we're not looking for random selection, of course, we're looking for random assignment, but essentially the same idea. So that's our 1 new condition. On to the fun part, the math. So first thing I'm doing, if I'm taking the AP exam, grabbing my calculator, looking at that table that I made, popping everything in. We're going stat tests. We've used letter A, which was the 1 proportions interval. Now it's a 2 proportions interval. The 1 means 1 sample of data. The 2 means 2 samples of data. The proportion means we're talking about percentages. And of course, that's what's happening here. We're talking about percents of people who snore. So I'm going to my calculator, stat test 2 prop Z interval, popping everything in. Copy down that calculator screen. You guys know I'm going to harass you about that. That way we'll always include the name of the interval at the top. We'll have the correct interval, and then we'll take a look at the formula. One thing that, kind of going back to the original question, if I jump back here, this question doesn't directly tell us to do a confidence interval, and if hopefully that happens on the exam, but maybe not. But we should know that that word estimate there means we need an interval. And so one major distinction between what we're doing now and what we were doing with the one prop Z. In one prop Z situation, we were estimating one thing, like estimate the percent of people over 30 who snore. Or another one prop Z interval would be estimate the percent of people under 30 who snore. Here, we're not estimating an actual percent of people who snore. Whenever we have two samples, again, going back to those two pictures, we're focusing on differences. So we're going to estimate, right, not percents of people, but the difference in percents of people who snore. And we'll talk a little bit more about what that means when we start to interpret the interval at the end. But we do know we can interpret the interval and just kind of copy wording out of the question for a lot of us. For me, like that's what I would do. That's going to be our best option. So we'll save that for the interpretation. But anyways, estimates the key word that tells us to do an interval. I intentionally did not give a confidence level because I wanted us to have to remember that estimate means interval. Let's just go with 95%, right? When in doubt, why not pick 95? So you can see here, top left, stat tests, shows my letter B, 2 prop Z interval. On the top right here, so I have my over 30 group as group 1, which is how I set it up in the table, I'm pretty sure. Yep. So we're good there. So my group 1's my over 30 numbers, my group 2 is my under 30s, and right, that's what I was talking about. So now which ones are the 1s and 2s? We'll go 95% confidence just because I'm feeling it. And then there down here we see our output screen, right? So on my AP exam, after I check the conditions, I'm literally copying this. Now, you might not copy these numbers because they're already in the table that you created, right? We don't need to be redundant. So in this case, you know, I'm realistically, that's a pretty terrible square. Realistically, I'm probably just copying these things because all of this was in the table that I already made. So far, so good. I'm just going to pretend you all said yes because I'm alone in my basement talking to myself. It's pretty weird. All right, so the formula. You can just copy the calculator screen on the exam. I'm glad that I'm telling you that via distance learning so that you guys don't also like throwing desks at me instead of making you like show all these formulas, but I promise that's coming from a good place, right? I just want us to understand what we're doing. So let's take a minute and look at like, how was this interval calculated? We should know, this is our formula sheet here. We should know that if we know how to read this formula sheet, right, there's our confidence interval structure. We'll come back to this when we're looking at tests. So far, everything we've been doing, we're looking at the proportions sections here. We've only worked with one population. Now we're talking two. It even tells us here, look, it's like, yo, do the difference, even though my arrow is not pointing to the subtraction sign like it was supposed to. And so for the standard deviation formula, we'll connect this to some review at the end of the video if you got a minute. But we're not assuming P1 equals P2 right now. Like pretty much you can do the whole exam, just so you know. I mean, we'll look at this. This is just like a bunch of algebra to manipulate the formula. Like if these two numbers were the same, you could start to do a bunch of factoring. If you're good at algebra, like go play with that, have fun. If not, whatever, don't even worry about it. So we really only care about this. So that right there, boom, there's our standard error formula. This right here is our statistic, and we should know our critical value is Z star. So for the formula, let me hop out of here and let me jump over to this so I don't have to try to write all this craziness with the mouse. So here's the deal, right? Statistic plus or minus critical value, standard error of stat. Stop looking at my hands. We know that, I hope, or I'm going to cry. We know this, right? This I just circled on that formula sheet, right? Two samples. So this is that giant square root p hat 1, 1 minus p hat 1 plus p hat 2, 1 minus p hat 2 all over n1 and n2. And so the only thing that's like, we got to think about a little bit over here now for our stat, like we don't have one statistic. We have two statistics, right? We got the p hat for the over 30 people, dudes or ladies. And we got the p hat 2 for the under 30 people. And then we start to picture that time Carafano gave us that weird warm up where it was like photo hunt that maybe they're going to do later for fun. Anytime we have two samples, we focus on the difference. And so this right here, this is how we're going to produce that interval. Now we don't have to do that because the calculator already did it for us. But right, obviously we want to try to understand where those values are coming from. So if I were to, I'll try to write this small enough to squeeze it on the bottom, replace all this. Now it's important again that you have the 1s and 2s in the correct order. So I should notice, right, like these are the two possibilities. Now, if you made the table I told you to make in the beginning, then you're probably not going to make that mistake. But we should also notice that when we created the interval, this doesn't really always work, but like we got positive numbers. So that should imply that this is probably not the right option because that would give me a negative. The other thing to keep in mind, your calculator always does group 1 minus group 2. So whatever you're entering in for the 1, it's always doing 1 minus 2. So I got P at 1 minus P at 2. We're using 95%, so that's going to be 1.96. And then I got 0.37. I could write 1 minus 0.37 or 0.63. That's easy enough. Over 811 plus 0.26. 1 minus 0.26 is 0.74, all over 184. And so, like, I'm not going to do it because I already know the final answer. But if I use that black formula, that's how we would produce those two values that popped up on our calculator screen, that 0.037 and 0.181, I believe it was. And as you might guess, there's still going to be stuff like this. Calculate the margin of error. If I ask you to calculate the margin of error, we should know that means do that. Or I might say just calculate the standard error. If I ask you just to calculate the standard error, we should know that just means, right, all the green stuff. And again, that formula is on the sheet. And so that's how the calculator is producing that interval that we saw on the screen. So that's the math. Good? I hope so. What's happening? Oh, yeah. Here we go. Turns out it's a slide for that, but I can't write all that with my mouse. So now we got to interpret the interval. Same process as always. Every interval, every interval. Conditions, math, interpret. If you were in class and I gave you a quiz and you did the conditions in math and didn't interpret, I'd yell at you. I'd give you a hard time because it's the same thing for every problem. Anyways, so this interval is a little bit weirder to interpret because, like I said, it's not just one percentage. We're focusing on a difference in percentages. So there's two ways to write the interpretation. We could just comment on the difference, and that's what we'll start with. That's in red because that's what I would do. That's just copying the wording out of the question. The other option is to actually really consider the actual meaning of the interval. Like the top sentence, the red idea there, like it might not mean that much to us. And then we'll look at a different way. It's more complicated, right? But it's actually what the interval means. For the sake of playing the exam game, I'm going with the red approach, the first one I'm going to do. For the sake of like real life understanding, we want to know what's up with the second. So same deal. We are whatever percent confident the true blah, 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 blah falls between blank and blank based on this sample. So if I'm jumping to the next screen here, right, this should look familiar to us. And I could start to fill in the blanks. So for us, I could just say, oops, sorry. So for us, we are 95% confident that the true difference in, now this right here, like, oh, you know what? That's really kind of part of this blank. So like, what were we estimating? If I jump all the way back to the beginning here, like what were we trying to estimate? We were trying to estimate the difference in proportions, percents of older and younger individuals who snore. So like that blank that we're about to fill in is this, the difference in proportions. That's what we're trying to estimate, the parameter, the difference in parameters. Let's jump here. Like I'm literally about to copy that in so you can start writing it. So we are 95% confident that the true little lag there. The true, let's keep saying that, the true difference in proportions of older, over 30, 30, and younger individuals who snore. Now this is here because it's important that we include the order of subtraction. The calculator always does 1 minus 2, but we have to specify that in this context. And you'll see when we get to this next slide, the last piece of the interpretation, don't worry, we're almost done. But you'll see that the order of subtraction is critical to understanding what the numbers in the interval actually mean. So we have to include that order of subtraction so we can make sense out of what the positive and negative numbers mean. I almost should have subtracted in the other order for this example so we got negative numbers so that like it wouldn't even be possible to think that those were percents of people who snore, but we'll touch on that in a second. So for us, we did over minus under 30. So we need that order of subtraction, right? We'll see that come up in a second because that's the only way we really understand what a positive or negative difference means. And so for us, we got between, I'm pretty sure, 0.037, or I'm going to write it as 3.7%, and 18.1% based on this data. So like that last piece, we know that if we take different samples, right, sampling variability tells us the sample statistics are going to vary from sample to sample. So if we know we took a different sample, we're probably going to, you know, well, not probably, we're going to see a different p-hat and get a different interval, right? So we're just specifying, hey, this interval is just based on this one data set here. We can just say, based on this data, keep it as simple as possible. That is what I would do on the AP exam. Unless someone who grades the AP exam watches this video and then tells you that that is not allowed, then like that's helpful. But other than if that doesn't happen, this is what I would write on the AP exam. I've been saying that for a while. So now the question becomes, all right, we're saying the true differences between blank and blank, but like, what is this 3.7 and what do these numbers really mean? Because like, these are not percents of people who snore. So now what we have to think about, those, that didn't really work out. So here, let me jump to this. Let's pop back over to my little whiteboard. So for us, we did over 30 minus under 30. The next video is going to be about an understanding if there's a significant difference in two percentages based on an interval for tomorrow. And that's going to connect back to this idea. So for us, when we subtract it in this order, we can either get a positive number or a negative number or 0. Both of the values in our interval were positive numbers. Think like, if I'm going to do over 30 minus under 30, and I'm going to get a positive number, which of these percentages had to be bigger? This one, right? That's a good time to like pause the video. It's kind of late to tell you that. But those are when you're watching a video like this, right? When I ask a question, pause it, right? Think about it. Don't just like see the answer, right? That's how you kind of engage yourself in this weird distance learning situation. But nonetheless, if we're going to get a positive, this has to be the larger percentage. So the fact, like a positive difference tells us that the percent of people over 30 who snored was larger. Now, if we subtracted the other order, it's possible someone makes their table. We called over 30 group 1 and under 30 group 2, but it's possible someone else creates their table and they call under 31 over 32. Like that's fine. There's no answer as to which one is 1 and 2. I would challenge you to think about if you did this. When we did the blue method, the interval was 0.037 and then 0.181. Think about this, or play with it and do it on your calculator. If you subtracted in this order, what do you think those two numbers would be? I'll leave that for you. But it doesn't matter which one's 1 or 2, so we're going to arrive at the same conclusion. This interval is going to be, it's not going to be these same two exact numbers, but it's going to lead us to the same conclusion. Kind of a hint is we know the over 30 people, like we have to arrive at the same conclusion that the over 30 is the larger percent. So down here in this case, if the over 30, if this is the larger percent, a smaller number, smaller percent minus a larger percent in this case is going to give us a negative difference. So if we subtracted in this order and got a negative difference, that's what would happen. That's still telling us that the percent of people who are over 30 who snored was larger. And so this all comes back to that idea that the order of subtraction is incredibly important, because the order of subtraction, right, it tells us or allows us to determine what a positive or negative difference means. It allows us to decide which percentage had to be larger. So since I did this order and got positives, I know that the over 30% was larger. Someone else in class, right now, maybe you flip all the numbers, you're going to get an interval with a bunch of negative numbers in it, but that's still telling you that the percent of people who were over 30 had to be a larger percent of people who snore. So this is now getting much more at what the interval actually means. This is less about playing the exam game. This is more about like what am I doing? What does this interval tell me? So the last thing we could look at, and then you could close the video, or there's one little tidbit if you want it. The last thing we could look at, wait, what am I doing? Is to interpret the interval based on its actual meaning. Now you're gonna have some questions come up where like, you gotta understand this for sure. This is definitely important. But, right, like for a free response on the exam, like I'm just writing that template. So I could say that, let's see, this should be the easy one, right? We're still 95% confident. Now we could say, what I would say here, what these numbers really mean is the percent of people over 30 who snore is actually larger. I know that because I got two positive numbers in my difference. How much bigger is the percent of people over 30 who snore? Between 3.7% and 18.1%. So the percent of people over 30 who snore is somewhere between 3.7 and 18.1% larger, excuse me, than the percent of people under 30 who snore, based on this data. Maybe with this online 45-minute exam, maybe copy and paste can become our best friend. So all those times I was like, hey, copy the whole context out of the question. And then you were like, oh, it's like so many words. Maybe we'll be able to copy and paste them, who knows? So now the true meaning of that interval, it's telling us how much bigger is the percent of people over 30. Again, over 30 was bigger because of the positive. So we're 95% confident the true percent of people over 30 who snores somewhere between 3.7 and 18.1% higher than the percent of people under 30 who snore based on this data. That makes sense, right? Old people snore or something? I don't know. I'm over 30. I snore. I think I'm asleep, so I don't know. Sleep. That's kind of a weird thing to say. All right. So that's the conditions math interpret. Close it out. Here's your practice. Well, actually, don't do that. Here's your practice. Nope. Here's your practice. Nope. Here's your practice. So this is actually a context from an AP exam. I just altered the question a little bit. So we're going to estimate the difference in survival rates using, oh, I wonder what that means we should do. Then you can see here I threw in a little effect on the margin of error interval. That's all stuff we know. Calculate a little margin of error. I referenced that in the video. So this will be posted on Google Classroom. You guys will just submit a picture of your completed work. I'll post a key. You grade it, right? This is all about initiative, right? This is all on you guys. You got to want to do it. You got to want to know you're right. Don't just submit some answer and never check it, right? Maybe you didn't learn anything. So it's on us, you know, in this weird quarantined world we're living in. But hey, we're going to get through it together. Office hours in 12 minutes. I'm sure I'll see a bunch of you guys. So that's that, unless you got a minute. You got a minute. Earlier, this came up on the screen. What's up with that? So the independent groups thing is important because it has to do with this variance as add. So like, what is that talking about? So right now, you should think about this. The question really is kind of getting at, where's this coming from based on this? Now combining standard deviations. Watch, see what I did here. So pause. Try to figure it out. It's kind of creepy. That's a hint. All right. If you're unpaused, this is literally the last part of the video. I know I've been talking a lot. This is one of the longest videos you guys will have. So here we go. Let's wrap it up. Let's close it out. Let's jump back over to the old whiteboard. Got two groups, right? Group 1, square root p hat 1, 1 minus p hat 1 over n1. Group 2, p hat 2, 1 minus p hat 2 all over n2. We want to combine those standard deviations. Can't add standard deviations. That's craziness. Why would you even say that to me? You can't just add them. You can't subtract them. We're finding the difference, p hat 1 minus p hat 2 for our statistics. Sure, that's fine for the expected value. You can't do that with standard deviation. What are you, crazy? Variances always add. Turn that into a variance. Boom. P hat 1, 1 minus p hat 1 all over n1 just gets rid of the square root. Turn that into a variance. P hat 2, 1 minus p hat 2 all over n2. Variances always add. Always. I don't know why the video makes me want to whisper so much. But right now what I have written in blue and red, that would be, I'm just pushing the whole camera back trying to slide the board up. This, that's a variance. How do I turn it back into a standard deviation? Oh my God, it's the formula that's on the formula sheet. Nothing crazy going on, just variances always add. Peace. Except not peace, because I was just stopping sharing, but now, peace.